So thank you very much the introduction. Who's here is okay. So I'm Takashi Shimokawabe from the University of Tokyo and the R-CCS. This presentation will introduce the activity of the application research group of this feasibility study and show some of the result of some of its subgroups. The group leader, the Professor Iwashita, is unable to attend this meeting, so I will make this presentation instead. So here is the overview of the application research group. So the application research group consists of the 12 subgroups. The subgroups comprising the application field of the computational science, the social science, and the data science will conduct research on the computational resources required to realize the leading edge research result with the next generation computing infrastructure. So we investigate a wide variety of applications using the general indexes such as the total computation, the arithmetic performance, memory usage, and the internode communication performance. And in addition to the general indexes, this research includes the survey of the various indications that define the characteristics of the application programs, such as the byte flops, the SIMD instruction utilization rate, and the productivity. So in parallel with the investigation of the individual applications, so we are investigating the communication avoidance and the communication reduction type algorithms and the state-of-the-art algorithms in machine learning and from a common perspective for the applications. So we will then investigate the necessity and the characteristic of these algorithms in the application running on the next generation computer infrastructure. So after the investigation, we will develop the performance models to estimate the application performance in the next generation computing infrastructure. In the developing performance models, we will work with the architecture research group to consider the architectural characteristics assumed in the next generation computer infrastructure. And we built the benchmark or maybe the micro benchmarks that reflects the characteristic of the representative applications. The developed benchmark marks will be provided to the architecture research group and the system software and library research group to contribute to the promotion of these research studies. So based on the feedback from the architecture research group and the survey result of the new algorithms, the subgroups in the application field review the target problems on the next generation computer infrastructure and reflect them in the science roadmap for each field. Through the above survey and research activities, so we will clarify the role that the next generation computing infrastructure should play. After clarifying the performance and the function that the system should fulfill to achieve them, we will extract applications to be evaluated in the collaboration with other groups. So in order to conduct these studies, so we have adapted the organization shown in this slide. The entire application research group is divided into the 12 subgroups. And of the 12 subgroups, 8 are classified as pure application groups, where subgroups belong to the various scientific fields, such as the life science, the fundamental science, and the weather and climate, etc. Then, on the other hand, the 4 subgroups are called the computer science group, CS group, to which belong subgroups that work on the algorithms, the benchmark building, and the performance model buildings. The CS group does research on the common algorithms in the various scientific fields. The pure application group cover a wide range of the applications. And each of these fields also, each of these the subgroups also naturally includes the several different applications with the different characteristics. And for example, in the life science field, they cover the multi-layered and complex phenomena from the atomic level to the cells, organs, and individuals levels. And a wide range of the simulation methods are used in this area, and the collaboration with the machine learning and the experimentation is also very important. And another example is the social science case, that they utilize the agent-based simulation to predict the automobile and pedestrian traffic, and with the AI-based analysis. In the weather and the climate subgroups, so they cover a wide variety of the weather and the climate models for the predicting the meteorological phenomena, climate, and the Earth system. So depending on the spatial temporal scale of the interest and the primary usage, that is means for the purpose is the research purpose or the industrial purpose, the forecast purpose. So they will provide about the 7 models for benchmark construction. And in addition to the data simulation, so there is the collaboration with the AI and machine learning. In the field of the earthquake and the tsunami disaster prevention and the manufacturing, the usage of the surrogate model, the AI-based surrogate model has been attempted. So because of the importance of this and the integration of the simulation and machine learning, so we have set up the subgroup for the digital twin and the society 5.0 in this pure application group. And the pure application group has so far investigated the standard analysis and the large scale analysis, that means grand challenge, that has been done by Fugaku and other supercomputers. So in particular, we have investigated the amount of computation, the amount of data, the data transfer, the amount of communication and their types, and also the amount of I/O. And we conducted a survey regarding the expected achievement of each application around the 2030. And the resource and the calculations required to achieve them. It includes the request related to the programming environment. So currently, we are forecasting on the developing our benchmarks. So in addition to the traditional benchmarks, so we are considering the workflow benchmarks, such as the integration of the computational science and the machine learning. So then from now on, based on the information from the architecture research group, so we will consider the feasible outcomes around 2030. And we will study the effect of introducing the new algorithms, such as the communication reduction algorithms. And the CS group is working on the following the activities. And the machine learning algorithm subgroups selected the machine learning benchmarks from MLPath, and scientific computing algorithm subgroups are investigating the space-time tiling and the communication reduction algorithms. And the benchmark construction subgroup is working with the pure application group to develop the benchmarks, and some of which have already been provided to the architecture research group. So the collaboration with the other groups is very important, but this is the kind of the chicken or egg situation. So from the application researcher side, without some knowledge of the knowledge of the architecture, it is impossible to examine what can be done and what should be done. And from the architecture research side, the significance of the system to be developed is indicated by the applications. What is the killer application? And without knowing the bottleneck in the current application program, and it is impossible to design it. So to promote the smooth collaboration, the surveys are being conducted from the architecture research group and the system software and library group to share the request and the bottlenecks from the application side. And And in the interview with the individual subgroups in the pure application group are also planned. So next, I will show the example of the subgroup activity. So here is the digital twin and society 5.0 subgroup. So the digital twin and the society 5.0 is expected to be utilized in various fields, and I mentioned such as weather and climate and material and manufacturing, so on. And this subgroup is investigating how the digital twin is constructed and utilized, how the system to realize the society 5.0 are constructed, and investigating and analyzing the necessary computational resources and technologies to realize the integration of the cyberspace and the physical space, or simulation and machine learning. In particular, so the analysis of the workflow is important for the digital twin and the society 5.0, which is often realized by combining the multiple applications with different computational and communication characteristics, such as the data acquisition, the simulation, analysis, machine learning, and the data processing and visualizations. So integration and the integration of the simulation and the data and learning, so is important toward the society 5.0. So the pie chart on the upper right shows the utilization field of the system operated by the Information Technology Center at the University of Tokyo, where I belong. So it is clear that the CPU cluster and the GPU cluster are very different in the utilization field. So therefore, we now operate the Wisteria VDEC01 system, which is the platform for the integration of the simulation and data and learning. So it is the heterogeneous system with two types of nodes, the simulation node for the HPC, the Odyssey, with more than 25 petaflops, is based on the Fujitsu system with A64FX. And this part has the same architecture as that of the Fugaku supercomputer. And the data and learning node Aquarius are GPU cluster consisting of the Intel Ice Lake and the NVIDIA A100 tensor cores with 7.22 petaflops for the data analysis, AI, and machine learning workload. And so using this Western system, we are now building the benchmark code of the atmosphere ML coupling. So this simulation includes two parts. One is the high-resolution model for the detailed simulations. Another is the coarser model for the parameterization. So we are replace this coarse model for the parameterization with AI. This path required 25% of the total computation time. So then in this machine learning process, the air density, the internal energy, and the density of the water vapor, the input, and their gradient in time direction is the output. The PyTorch is used as a framework for the machine learning on this Aquarius. The left-hand side is the input, the middle is the output by the simulations, and the right-hand side is the output by the inference. So generally the simulations and AI are really well. So by using the libraries that can communication between the different type of systems, that means the CPU and the GPU in the heterogeneous systems. So we are building the benchmarks that allow us to investigate the communication performance in the various communication patterns. For example, the Odyssey is the CPU-based system, and the Aquarius GPU-based system. And this is one of the pattern, and another pattern is CPU and the CPU case, and also we change the communication library. That means the socket-based one and the file-based one, and the ordinary MPI-based one. So we will provide this kind of the application for the workflow benchmark. And another benchmark code we will provide for as a digital twin is the local wind simulation with the mesoscale meteorological data simulation. This is the GPU acceleration type of application, and the performance of the data simulation will be investigated in the benchmark code. And here is a summary of my talk. The application research group is the very wide range of the scientific field, and consists of 12 subgroups. And our goal is the research on the computation results is required to conduct the leading edge and research with the next generation computer infrastructure. And also another goal is provide the benchmark. So that is the conventional traditional benchmark, and also the workflow benchmark for the integration of the simulation and the machine learning. That is one of the examples. And for this purpose, we create the one subgroup as this digital twin and the society 5.0. And I showed some of the benchmark code the case of this atmosphere ML coupling. Thank you very much.